Hello and welcome back to another video. In today's video, we will continue studying distance versus time graphs. And now that we know how to analyze distance versus time graphs, we'll be learning how we can create our own distance versus time graphs to represent the motion of any object. So let's get started looking at the steps we can use to create a distance versus time graph. So the first step we need to follow in order to create a distance versus time graph is to set up our intervals. It doesn't matter which interval we start with, but we'll just go ahead in order and start with our x, which is our time axis. So first we need to figure out how are we going to separate the intervals on the time axis. In order to do this, if you're not sure how, there's a helpful formula we can use, which is taking the largest time value, the largest value we'll be putting on our x-axis, and dividing it by the number of squares that we have available on the axis. That will give us the number that we should use to divide our axis into equal intervals. Once I've calculated my interval, I will go ahead and actually label my intervals on the time axis.
So using the formula, x interval is equal to the highest x value divided by the number of squares on the x-axis. Looking at my x-axis, I can see that I have 10 squares available on this axis. Looking at my data, I can see that the highest time value is 5. So I will plug in 5 over 10, which gives me 1/2. This tells me that each square on the x interval should be equal to 0.5 seconds. Now that I know my interval, I will go back and label my x-axis with the appropriate variable and unit, time and seconds, and then mark each interval with the appropriate time. Now I know that half a second can easily be put to 1 second, so I'm gonna skip every other square and just mark my whole number time values. So you can see here that my intervals are all set up and I have ample space on my axis to put in all of my x value.
Now that we've set up our x-axis, we'll go ahead and repeat the exact same process for our y-axis, which is of course our distance axis. We'll use this same formula by using the largest distance value divided by the number of squares on the y-axis. Once we calculate this, we will also go ahead and use that interval to label all of the intervals on our y or our distance axis.
Now we'll move on to our y interval. We'll use the same process to calculate the interval for the y-axis, looking at my highest y value and the number of squares on the y-axis. This is a 10 by 10 grid, so I do have 10 squares on the y-axis as well, and I see that my highest y value is 2900. I know that 2900 divided by 10 is 290. But 290 is not a nice even number, so I'm going to go ahead and round it to 300 so that I have nice even numbers on my interval. So that tells me that every square on my y-axis should be equal to 300 meters. I will now go ahead and repeat the process, marking each one of my squares on the y-axis with its appropriate distance unit. I also will label the whole axis with the variable, which is distance, and the unit, which we know is meters.
Now that our axes are all set up, we're ready to plot our data points. So we'll take the data that we have on the object we're graphing, including its distance traveled and time of travel, and we'll start by plotting our first data point. I'll start by finding the time value of that data point on the x-axis. I'll stop at that point and then go up along the y-axis until I find the distance I'm looking for. Once I arrive at that point, I will mark the data point with a dot. Now I've plotted my first point. Now, in order to create the distance versus time graph, I will continue and repeat that same process for all remaining data points. Once we have a graph with set up axes and plotted data points, we're ready to finally draw our line. All I need to do in order to create my line is to draw a line connecting all of the data points that I've plotted. This means that my line should pass through every single one of my data points. Whether or not it is linear is based on the motion of the object that you've plotted. Once you've drawn your line, you officially have a complete distance versus time graph, which you can then analyze to determine the velocity and acceleration of your object.